Today we're going to be looking at arc length. So this is very similar to finding the area of the sector of a circle. So if we're talking about arc length, what we're talking about is a distance on the outside of the circle. So we know that if we're talking about going all the way around the circle, that distance, that is our circumference. And the formula for that is 2 times pi times r. So in order to find arc length, which is just going to be a portion of our circle, we're going to do something similar to what we did yesterday, where we take a portion based on the central angle. So for this one, it's 110 degrees, and all the way around is 360. So that's the portion of the circle we're going to use. So we're just going to take that and multiply it by the circumference. So our arc length formula is going to be equal to x degrees times 2 pi r, which is our circumference, divided by 360. So that's going to give us just the arc length of that piece of the circle. So as an example, we'll go ahead and use this one. Our angle, central angle is 110. We're going to multiply that by 2 pi times our r, which is 5 feet. And then we're going to divide the whole thing by 360. Our answer then is 9.6, and that's just feet. So that would be just this length right there. That's our arc length. I just want to make a couple of notes on two things here. These relate to your practice problems. So if you have a problem that has like a circle, but then it doesn't go all the way around, and then something straight, kind of like this, you're going to be finding the arc length of just this piece. On one of the problems, it uses a Greek character for the variable. So this is alpha is equal to 280 degrees. They could have just as well put x is equal to 280 degrees, so don't let that throw you. That's just saying that this central angle here is 280, your radius is 35, so you're going to put that in the arc length formula. The other thing is, another problem has an equilateral triangle. It tells you that all three of those angles are 60 degrees. And we just remember with an equilateral triangle, all of our angles are congruent, and then all of our sides are also congruent. So if this is 50, that's 50, and that is 50 as well. This is a problem that is similar to problem number 6 in your slides. It's not exact, but it's similar. So if we have points B and C that lie on a circle, and the radius is 7 units, they also are telling us that the arc length for this problem is 13.5 units. And the question is, we want to find the measure of angle BOC in radians. Okay, so what that means is they've actually given us the arc length this time, and we need to find that central angle, which is x degrees, and they want the answer in radians. So we're going to get the answer in degrees first, and then we'll deal with converting it to radians. All right, so that means for this problem here, I have the arc length. So I'm going to say 13.5 is equal to, I'm going to leave that x, that's what I'm trying to solve for, 2 pi times the radius, which is 7, and I'm going to divide that by 360. So when we work that out algebraically, oh, I know, one thing is in this problem, it will ask you, instead of using pi, to use 3.1416. That's how far it goes out. So let's go ahead and do that. All right. So when we do this algebraically, we're going to multiply that together, multiply both sides by 360. We end up with 4860 is equal to something like 43.9824x. And then divide both sides by the 43.9824, and we get x is equal to 110 it's essentially 0.5 degrees. So what that means is that our answer here for x in degrees is 110 degrees, 110.5 degrees. So now we're going to take this and we want to convert it to radians. So if you remember when we were doing our trig problems on the calculator, we had two modes that we could choose for angles. We could choose degrees or radians, and we always made sure that we were in degrees. But for this problem, they want us to give us the answer in, give them the answer in radians. So radians is just another way to describe this measurement here. and we typically use pi with it. So the way you convert a number of degrees, like 110.5, to radians is you're going to multiply whatever that number is. In this case, it's 110.5. We're going to multiply it by pi over 180. So we're going to have 110 in your calculator times pi divided by 180, and our answer is going to be it's like 92999 radians. And then, you can just round it to whatever they ask you in the problem to do, but because there's so many nines, I just went ahead and put those on there. Okay, so take your degrees and multiply it by pi over 180. That's how you always are going to convert degrees to radians. And then for this problem, which is similar to number 6, not the same, that would be your answer for this one.